Today, we'll show you how an amazing engineering project can be built using simple, everyday materials. This creative journey begins with a small DC motor, a 20 milliliter syringe, and an ordinary pen. Although these items may seem ordinary, they can be transformed into a compact and highly efficient water pump by applying a few basic principles of science and engineering. This project is a perfect example of how creativity and practical skills can turn simple household materials into a functional mechanical device. First, the syringe plunger is removed and the black rubber seal is carefully cut off. The remaining plastic rod is trimmed to a specific length using a hacksaw. It is then carved with a utility knife into the shape of a small impeller, carefully balancing each blade to ensure smooth rotation. After shaping, the surface is polished with sandpaper to remove rough edges and improve water flow. Finally, a tiny hole is drilled through the center so it can be mounted securely on the motor shaft. Next, a hole is made in the middle of the black rubber seal, which is fitted onto the DC motor shaft to act as a waterproof seal. This small rubber piece plays an important role by preventing water from leaking into the motor housing. The handmade plastic impeller is then securely attached to the shaft using strong adhesive, ensuring that it remains perfectly centered during high-speed rotation. Proper alignment at this stage is essential for maximum pumping efficiency. The outer body of the syringe is modified by cutting its rear end and drilling an additional outlet hole for water flow. The chamber is carefully cleaned to remove any plastic particles left behind after drilling. Once all the components are ready, the motor is carefully installed inside the syringe body and fixed firmly in place with adhesive. Every joint is sealed to prevent water leakage, resulting in a compact, lightweight, and highly efficient portable water pump that is both durable and reliable. Using nothing more than an empty pen barrel, a small plastic syringe, and a tiny DC motor commonly found in toy cars, you can build an impressive science project. After carefully cutting the pen to the required length, it is attached to the syringe chamber at a 90-degree angle, creating an efficient pump housing for water transfer. This simple modification forms the inlet passage, allowing water to enter the pump smoothly with minimal resistance. The most important step is sealing every joint with super glue and hot glue to make the pump completely waterproof and protect the motor from water damage. Careful sealing also improves the pump's overall performance by preventing air leaks that could reduce suction. Once the electrical wires are connected to the motor terminals and powered by a battery, the spinning impeller generates a strong centrifugal force inside the chamber. This force creates a pressure difference that draws water in through the inlet and ejects it as a steady, high-speed stream through the outlet, demonstrating one of the most important principles of fluid mechanics. As the impeller spins faster, the pump becomes more efficient, delivering a stronger and more continuous flow of water. Despite its small size, this homemade device can move a surprising amount of water, making it an excellent demonstration of how centrifugal pumps work in real-world applications. The same scientific principle is used in many household appliances, irrigation systems, aquariums, cooling systems, and industrial water pumps. This compact water pump is perfect for school science projects and for demonstrating the basic principles of hydraulics, fluid dynamics, and mechanical engineering. It can also be used to automatically water small household plants, circulate water in miniature decorative fountains, or perform simple educational experiments.